Hey, what's up? It's Mike. I wanted to do a quick show and tell about a project I've been working on this weekend. Something that I've been wanting to build that would be an Edge Impulse project that I would actually use like every day. And inspired by the HP Poly keyword spotting headphones, I decided to put together a wireless, fully remote, localized voice assistant that would turn my music on or off by voice command. It's a Raspberry Pi Zero 2W with a Seed Studios re-speaker hat on top of it. I trained it with a lot of different samples of me saying a couple keywords, and now I can do this: Sonos play, and my music turns on. And I can say Sonos pause, and my music stops. It's perfect, and it's super convenient, and I no longer have to reach all the way over here to pause and play my music. Actually, it's really for the kitchen where the speakers are up on top of the shelves and you can't reach them. But the coolest part for me is the dashboard that I then enlisted Claude to put together for me, which allows me to do a lot of additional training and upgrades on it. And I want to show you that part right now. So let me jump over there. All right, so this is the dashboard, and you can see I have a number of different panels inside of this, but the big idea with all of it is that I wanted something that was super specific to my device and what I wanted it to do. There's three main parts to all of it. There's the hardware, there's the software, and then there's the Edge Impulse model that runs all of it inside of how it works. So let's go through these different sections here. Right at the top, you can see live scores. I've got 5 different labels that I've trained with a number of different samples for each of them. Noise, which is any sort of background music or ambiance or a fan droning in a quiet room. I've got my 3 keywords. These are the commands that actually create a response. I've got Sonos pause, Sonos play, Sonos mute, and then below that unknown, which would be any speech that's happening that's not one of these keywords or commands that happen in there. And you can see they are responding live as I'm talking, and it's all happening off of the device, which is sitting right next to me right here. The entire dashboard and all of the functionality happens on the device itself. This is all housed inside of the Pi, and it connects directly into Edge Impulse through the API, which is actually quite powerful. From there, you can see a section, our last detected keyword, which just happened a few seconds ago when I said the Sonos mute keyword. You've got some system stats. Always helpful to see if the computer, if the Raspberry Pi computer is running effectively, how much memory it has left, etc. And then an additional detection history window here that shows all of the different keywords that it's heard over a period of time, which can be really useful if you're really trying to fine-tune how many false negatives you might be experiencing and detect that that's becoming an issue or not. From there, we get into a section here that is the thresholds controls. Now, when I first built this, the dataset was a lot smaller and I was not getting as much responsiveness out of the keywords. So I had to keep a lower threshold on what the software would think was an actual command that required the trigger to happen. And as I started getting a better data set put together, I needed to start bumping that threshold up. But it becomes a little bit cumbersome to do this over and over and over again as you need to make these changes using the command line and terminal and changing one figure, but then having to recompile and upload all of the information back to the Pi and then open up the new software and test to see if it works. So instead, I had this put together, which are live sliders that on the fly control the different thresholds amount, the confidence that the software needs in order to create the next action based off of the keywords that it's listening for. And this has been super useful. As the model's gotten much more robust and powerful, I've actually kept these up at the 97% confidence level because it is performing that well and the keywords are being understood that confidently. I can also control the mic level on the Pi hat the microphone hat itself, which I found to be a little bit hot. The gain was high, some of the audio was clipping, but I can dial that back a little bit and make sure that it works the way that allows us to perform most effectively. From there, I also started to think about what I wanted to do for adding some more training to this. Now, we've all heard that a model is only as effective as the data that it's trained on. This is repeated over and over and over again, and I really started to take that serious as I've been working on this. And I've really tried to build a super accurate data set with this. Knowing that having this here on my desk with the microphone next to me is one thing, but eventually I'll want this device to live somewhere else in the office and possibly on some shelves behind me, which means that at some point I'll have to re-record all of my data. And when I do that, I want it to be easy to do. So I added this to the dashboard, this model training window here, and you can see it allows me to choose what type of label I'm going to add data to, how long I want to record for. I've got a record button, which will then allow me to record. And I'll show you how it works right now. So let's do a quick test run with the Sonos mute command. So it takes a second. Now we say Sonos mute, Sonos mute, Sonos mute, Sonos mute, Sonos mute. And you can see one of those actually came in a little bit hot. I click this, it uploads it to Edge Impulse, directly to my project, into my data set, in this 5-second sample here. And then it displays this waveform. I can find segments within this and I can review them. So let's listen to this first one, which was me talking. This one's not an actual sample. Second, now we say, no, so we don't want that. Double click it. This one here is where you saw that red line. It clipped when we were recording. Sonos mute. And I don't like that because there was a clipping. It might not be good for this data set. So let's double click this to get rid of it. Sonos mute. That one sounds good. Sonos mute. That one sounds good. And now let's add one more and bring it here. Sonos mute. All right, so 3 samples. We'll save these. It's going to split this data in Edge Impulse and add it to my data set, which will then allow it to be included the next time I retrain this model. And below that, if I scroll up here, you can see I've got a retrain and deploy model section inside of the model training box. This shows how many samples I have collected all together, 300 for noise, 243 for pause, etc. But also how many samples I have since I've run the last model. I've added 6 new to Sonos Pause. I've added 3 new samples to Sonos Mute, which were the 3 that we just recorded right now. And then with those, when I feel like I've got an adequate number of new samples, I can click this Retrain Model button. It will rerun the model training and give me a confidence score right on the screen here. It'll show the matrix and let me see that it is performing effectively, or if it's something went weird, I'd probably detect that pretty quickly. I can build and deploy and then activate the new model right on the Pi itself, and it all happens right off the dashboard. It's really cool. Now, if something goes badly with that new model and it does not perform well, I've also added in this rollback feature right here. The Raspberry Pi itself is actually storing the 2 most recent versions of the model that we have trained with Edge Impulse. The current one that's running and then the previous one. And if the current one is something terrible with it, I can click this red button. It'll roll back to the previous one so I don't lose any, I don't have any downtime where I have to retrain the entire thing and search for bad data that has ruined that one. I can stay up and running while I then go and clean that up. And if for some reason that does happen, I've also saved everything to GitHub, so I can go back weeks or months and I can pull up old models and use those if there was one that happened to be great from a long time ago. So One other thing, as I've been going along with this, and this gets into, again, the obsessiveness that I've started to have with the data, is I wanted to figure out a way that I could actually use this device to train itself to a degree. So I created this audio capture mode, and what this is it's a self-recording function that listens for any of the triggers that happen and records them when they do happen. So if I'm getting a lot of false positives because I'm playing some music and the model thinks that there's a part of a song that actually is me saying Sonos pause or Sonos play, it will record that section, and then I can relabel that inside to allow me to then train the model further and make it even more effective. I can train out those false positives and make this model even more robust. And it works well. And what I did with it last weekend, I was away from home, so I actually just let the radio play in the office for the entire weekend and had this capturing all sorts of samples of radio DJs and NPR and classical music and other types of music. And then I remotely SSH'd into this because, again, I'm kind of obsessive with it, and I've put Tailscale onto the Pi so I can go in and I can look at my dashboard remotely. And I retrained the model halfway through the weekend, and it worked. It trained out a lot of those false triggers. And the next round, as it then went and continued to listen, I had many, many fewer triggers from the model that were triggering. And at this point now, it's gotten so much more effective and useful. So that's really been a very fun part for the whole process. And then one last thing that I want to show in here, which is the newest thing that I've just added to this. Inside of the model training box, I've added a review low confidence samples. Now, one of the other things that I want to make sure that I am always keeping tabs on is that I haven't mislabeled any information, because it can be hard to go through hundreds and hundreds of samples. So running this analysis to look for any of the low confidence samples that come up in the data set allow me to go through and listen to a big bulk of these. I've got about 600 and something samples altogether for the keywords, but the ones that are coming up at the lowest amount of confidence, the model will flag those. It'll pull them up for me. It'll let me click this button, a play button for each of the samples, and listen to them and review to make sure that they are exactly what they're meant to be. So let's do a couple of these real quick. That one's a little bit of nothing. This one is. That's just some jazz piano and a drum in the background. Now it's labeled as noise. The model thinks it's unknown speech. I don't know why. It doesn't sound anything like speech. It's correctly labeled as noise. So we're going to keep this as it is, which would mean me clicking this green button right here. But before I do that, I also want to show one more thing that I added to this because, again, getting kind of overboard with this. I've added another model into this. It's another Edge AI model that is a voice detection model. And it runs on every sample that comes through the data set, through the dashboard, and it determines whether or not it hears speech. In this one, it doesn't hear speech. So the model thinks that this is an unknown speech sample. The voice detection algorithm says, no, there's no speech here. So it's actually suggesting to me that this should be unknown. I can keep it, which would keep it as unknown, or I can just click this use button since let me say that again. So the voice detection says it's not speech, which means that we're not going to go with the unknown label. We're going to keep this as noise. So I'll click this green button and it stays as noise. Now this next one here, it does detect speech. So let's listen to this and see what it's hearing.
Sonos,
And that's me. And one of the keyword label samples that I've done to try to train out just the word Sonos, it is supposed to be in the unknown data set. This is just speech. It's not a keyword. So it thinks that I'm trying to say Sonos pause, but we want to keep this as unknown. So I'm going to keep this here. But you can see it detected speech, so that was correct. So let's go ahead and click that keep button. And this lets me really help keep this entire data set really solid and strong and correctly labeled. I've only had to change a handful of the samples, but even just by changing a handful of them, the performance of the model has gone up considerably and the accuracy of it as well. So this has been something that's been really pretty useful for me. A little bit of work to go through, 33 samples, but not impossible, and I'm glad I have it. So that's my dashboard. This is the device. I use it all the time, and I'm really excited about what's come together with it, with the dashboard, with the API, and just overall with what Edge Impulse can do to create something that's as effective as this is. So very very thankful to the Edge Impulse team. Thanks for putting this together, and I hope you like it, and I hope it gives you some ideas for something that you could build too. All right, well, have a good day.